All right, so surface area of cylinder. So surface area of a cylinder, we're still dealing with surface area just like we did with the rectangular prisms. What type of units are we dealing with surface area? Squared or cubed for surface area? Squared, okay? Because remember we said like with your cereal box, if you kind of like open it up so that when you're putting it in the trash or recycling, it's flatter and takes up less space. It's actually a flat surface you're calculating. So it's the same idea with cylinders. Surface area of a cylinder is the number of square units that it takes to cover the shape. So again, we're talking about the outside of the shape if we're talking about surface area. Volume is the inside, surface area is the outside. So your formula, and this is straight from your formula sheet, 2 pi r squared plus 2 pi r h. So if you've noticed, when we're dealing with surface area, we tend to have addition in our formula because you are adding the different surfaces together. Now the first part of this formula, the 2 pi r squared, okay? Part of this part we have seen before in 6th grade. You need to flip back to your formula sheet and see what part of this 2 pi r squared have we seen before in 6th grade, and what was it calculating? What part of that looks familiar? What part of the 2 pi r squared looks familiar? Here's my formula sheet. What part looks familiar? Had to do with circles. Okay, 2 pi r was the circumference. What else are you looking at there? What's the formula for area of a circle? Pi r squared, okay? So we're really looking at, when you're looking at that part of the formula, the 2 pi r squared. Pi r squared is the formula for area of a circle. So why do you think when we're talking about finding the surface area of a cylinder, there might be a 2 in front of the area formula? There's a 2 in front of the area formula for a circle. Why? How many circles are there in a cylinder? 2, the top and the bottom, right? So this part of the formula, it's finding the area of a circle and doubling it. Because there's 2 circles, the top and the bottom, that make up your cylinder. So this part of the formula, it calculates the area of the top and the bottom. Because that part of the surface area formula is dealing with the 2 circles that make up the cylinder, the top and the bottom. Looking at the second part of this formula, the 2 pi RH. Part of this, part of the formula, not the whole thing, but a chunk of it, again, should look familiar from last year. Should be a formula that's on your formula sheet. Part of this 2 pi RH. What part looks familiar? Look back at your formula sheet. What do you think? Not the area of the circle. The circumference. The 2 pi r is the circumference of the circle, okay? So this part, it's the circumference of the circle times the height. What that is solving for was a keyword or vocab word we put in our notes last week when we were talking about volume of a cylinder. And I said we'll talk about it more next week. Do you remember what the part of the cylinder is called that like wraps around the circle or the circles? I think somebody said it. The circumference is the distance around it, but I'm talking about if I had like my coffee mug, right? And because this is roughly a cylinder, and I were to wrap a piece of paper around the outside of it, okay? I'm not covering the top, I'm not covering the bottom. L. What? What'd you say? No, I thought you said it for a second. Lateral? It's the area of the lateral surface. We put it in our notes last week, and I said we will deal more with it next week with surface area. So if I unwrap this paper that is like the lateral surface area around my coffee mug, what shape is it when I unwrap it? But what shape is this? It's a rectangle, okay? So when you are actually using that part of the formula to find the lateral surface area, that is solving for the area of the rectangle. So you're finding two different areas. You're finding the area of the circles, you're finding the area of the rectangle that wraps around the circles, and then you're adding them together. That is the surface area for the entire cylinder. There are instances, and we'll see a couple examples in our notes, where you are not going to use the entire formula because you're not covering the entire cylinder with something. So that's why it's important to know what the different parts of the formula represent. That way you can figure out what part you need and what part you don't need, okay? So now into our examples. So our first one here, we're finding the surface area. Obviously these are pictures of cylinders, so we kind of have the shape part already figured out. And then it says surface area, so that's what we're solving for. So that tells you the formula that you're using. Formula for surface area of a cylinder. Write down the steps I'm writing down. I'm not going to necessarily show as many steps on the second page, but write everything down on this first page. So that if you don't have your laptop and you need to work this out with a handheld calculator, you know what to do. So our formula, 2 pi r squared plus 2 pi rh, okay? With everything we're doing in class, what are we using? What are we substituting in for the value of pi? 3.14. When I substitute in the values for this particular example, what is my radius? And what is my height? Good. Okay. So I substitute in 3.14 for pi times my radius of 5, and that is squared. That's that first chunk in the formula. Plus 2 times 3.14 times my radius of 5 times my height of 10. Okay? If you have Desmos, you don't have to type in all of those numbers. You can type in your formula and type in what your variables are equal to. So I'm going to start with the formula, and again, instead of using the pi button, I'm using 3.14 times r squared plus 2 times 3.14 times my radius times my height. We said our radius is 5 and our height is 10. Oop. There we go. And so that makes our surface area 471. Our units were centimeters. And what exponent do we use for surface area? A 2 squared. Okay. 471 centimeters squared. That is the surface area for all sides of this cylinder. All right, our next one. Same thing, finding the surface area of this cylinder. So I'm going to start with my formula. 2 pi r squared plus 2 pi rh. For pi, it's 3.14. What is the radius of this cylinder? 10, good. And the height then would be 6. Even though this is laying sideways, the height is always the distance between your two circles. So I'm going to substitute those in. So 2 times 3.14 times my radius of 10, and that gets squared. If you are working this out by hand, because you don't have Desmos, you have to kind of work out these two chunks of the formula separately. And when you're working out this first portion right here, I would have to make sure to square the 10 before I multiply by the 3.14 and by the 2, because that would be following your order of operations. Then the second part, 2 times 3.14 times a radius of 10 and times a height of 6. All I have to do, since I already have my formula in my calculator, is change my radius to 10 and change my height to 6. 6, there we go. And then that is my surface area. So 1004.8, and then that is yards squared. Okay. Moving on to my 2 on the bottom. What do you notice immediately is different about these two? They give you the diameter of the circles instead of the radius. So we're going to have that extra step to calculate the radius. So our formula to start. Again, even when you are doing this on your own, I still want you to write down the formula. Even if you're not writing down all of the substitutions because you're doing that part in Desmos, write down the formula. Because sometimes, now that we have all these formulas we're dealing with, and we're going to work with word problems too, the issue might not be how you substituted your values in, it might be the formula that you started with. So 2 pi r squared plus 2 pi r h. So pi, we're using 3.14. So what is my radius? It's 3, because I take the diameter of 6, I cut it in half, and that gives me my radius of 3. And then my height is 9. So I will substitute those values in the second step. 2 times 3.14 times a radius of 3, that gets squared, plus 2 times 3.14 times a radius of 3 times a height of 9. Does anybody have their calculator up and wants to tell me what you got for your answer? What'd you get? Yes. So I change the radius, like we said, to 3. Then I'll get rid of the calculator on the screen and let you guys kind of help me with this so that I can make this a little bit bigger. But radius of 3, height gets changed to 9. If you are using 3.14, you should get the same thing. If you use the pi button, it would be slightly off. Make sure everything is typed in the same way that it is on the formula sheet. So that should be 226.08. Our units were miles. This is a very big cylinder. Squared. Okay, so then I will make this full screen for the rest of it. All right, so finding the surface area, start with your formula. Surface area, 2 pi r squared plus 2 pi rh. For pi, we're going to substitute in 3.14. What is my radius? What's my radius? 3.5. You have to take the 7 that's the diameter, cut it in half, and that gives you 3.5. And then your height is 11.5. We're going to substitute those values in. So 2 times 3.14 times a radius of 3.5, and that gets squared, plus, then the second part, 2 times 3.14 times a radius of 3.5 and times a height of 11.5. What did you get for your answer? Perfect. Surface area is equal to 329.7. My units are centimeters in this case, and they get squared because it's surface area. All right, so now we have our word problems with our truck here. So some of the word problems we had last week, we were talking about like a tractor trailer, which is a rectangular prism. In this case, this particular tractor trailer, it tells you the truck's tank is a stainless steel cylinder. So this is a cylinder, and there's also a picture provided. Usually if it's like a gasoline truck or milk or some sort of liquid, that's when you're going to see a cylinder for your tractor trailer. The question asks how much steel is required to make the tank. I'm looking for what keyword or words, there could be multiple you could pay attention to here, that would indicate that you are calculating the surface area rather than the volume. What do you think?
How much steel?
So I'm kind of looking at the steel here, yes, or the tank. Either of those words you could focus on, because the steel that makes up the tank, that is on the outside. You are not filling it with steel on the inside, okay? So because we're talking about the outside, that's how we know we're dealing with surface area. So I'll write my formula down, and on here I will skip like the individual step of substituting all the values in, save us a little bit of time because you have that on the first page. So 2 pi r squared plus 2 pi rh. For pi, I substitute in 3.14. What is my radius? Tells you that right there. And what is the height? 50, good. Again, this is sideways, but your height is the distance between the two circles. When I plug all that in, does somebody have the surface area for me already? What did you get? 2 times 3.14 times r squared plus 2 times 3.14 times r times h. What'd you get?
I don't know.
Okay. What'd you get? 1,356.48. These are feet, and it's squared because it's surface area. And then I'll kind of box this in here because this is your final answer. Number 6, Mary wants to make several cans like the one below. What shape are we dealing with? How do we know it's a cylinder? There's a picture, but what else? What word? Cans. Those are cylinders. Okay. She's going to cut them from a sheet of metal that has an area of 3,750 inches squared. Here's your question. How many can she make? How many of those cans can she make? So I am going to use the surface area formula, okay? And I'm solving for the surface area of a cylinder. So I can start with that. But this area that's listed, that is my total area. We're going to kind of come back to that at the end. So my surface area, 2 pi r squared plus 2 pi RH. Pi, we use 3.14. Radius, what's our radius for the can? Yep. 6 gets cut in half, so a radius of 3. And then my height is 5. So what is the surface area of the can? 150.72 inches squared. Is that the answer to my problem? No, I need to know how many cans she can make. So how can I figure out how many cans she can make out of the 3,750 square inches? Divide. So you would start with the 3,750, which is your total. I'm going to divide that by the amount of surface area needed to make 1 can. And what does that give me? It's kind of got a messy decimal with it. Yeah, 24.880557. It keeps going on, okay? But my question is, how many cans can she make? What would be my answer for this? 24. Why did you round down instead of up? There's an 8 in the tens place. Why did you round down? Yeah, you can't, there's not enough for 25 cans. So even though like you think, oh, I'm rounding, I'm going to round up, there's not enough steel for 25 cans. So, or whatever the metal is. So my answer to this would be 24 cans because you can't make a part of a can. And then I'm boxing that in as my final answer for the question. All right, number 7. Campbell's Soup is creating a new soup label. If a can has a height of 6 inches and a diameter of 4 inches, how much material does Campbell need for each soup label? What word tells me my shape? Can. Okay. So, and if I am solving for the label, is that the inside or the outside? That is the outside, okay? So that is surface area. So surface area equals 2 pi r squared plus 2 pi RH. Pi, we're going to use 3.14. What is my radius? 2, good, because I have to take the 4 that's the diameter and cut it in half. And what is my height? Okay. Here's the thing that we have to be careful of with this question. Think of a soup can. Does the label cover the top and the bottom? Or does it just go around the outside? So if we're not covering the top and the bottom, which part of this formula do I want to get rid of? Because it's the area of the top and the bottom. If you need to, look back at the page before this. Which part of the formula do we say is the area of the top and the bottom circles? Yes. The 2 pi r squared, that's the area of the two circles. It's the top and the bottom. We're not going to cover the top and the bottom with the soup label. Okay? So we can get rid of that part of the formula. So we're only using this part, the 2 pi rh, because that's the only part where my label is going to go. What was that part called? This part of the formula, what are we solving for? We wrote it on our page before this. What part is that called? What word is in front of lateral area, okay? Or the lateral surface. So because this is a label, over to the side, I'm going to make a note that you are solving for the lateral area. That's why we are only using that second part of the formula, okay? So then you have 2 times 3.14, because that's pi. We substitute in 2 for our radius and 6 for our height. So can anybody tell me what the area is that we need for the label? What'd you get? Yes, 75.36 inches squared. I'm going to box that in as my final answer. And then I can put like of material after that if you want to label it a little bit more specifically for our word problem. You need 75.36 inches squared, or square inches of material. Some of the questions you're going to have on your paper today is the back of the one you started on Friday. It asks for both the surface area, your total area, and it asks for the lateral area. If you're looking for the lateral area, it's just that second part. A couple of the word problems down at the bottom don't tell you specifically that you're solving for lateral area or the whole surface area. You have to distinguish it. So here's our last one. Brad is making a pencil can for his desk. He will wrap the can in paper. So again, we see things like it's a can, we're wrapping it, so the shape is a cylinder. We're wrapping it, so that tells us surface area. How much paper will he need if the can has a radius of 1.5 inches and a height of 7 inches? So surface area of a cylinder, starting with that formula. 2 pi r squared plus 2 pi rh. For pi, 3.14. My radius, I don't have to cut anything in half. It tells me it's 1.5 inches. And the height is 7 inches. If I'm going to cover the pencil can with paper, like to decorate it, am I going to cover the top and the bottom? Nobody's going to see the bottom, and if you cover the top, you have to poke a hole in it every time you put a pencil in. So this is, again, we are just solving for the lateral area. We are not going to cover the top and the bottom. So we cross out that part of the formula. We're just using this part. So what we're calculating is 2 times pi, which is 3.14, times a radius of 1.5, times a height of 7. What are we going to get? 65. Good. My pen will work. 0.94 inches squared, or square inches. And it asked how much paper will he need, so you could add kind of an additional label after this if you want. 65.94 inches squared, you could say, of paper, to just be a little bit more specific. Okay, so you have to distinguish, you have to read, okay, to figure out the shape, what you're solving for. Am I even going to use the entire formula, or do I just need part of it? You have to pay attention to detail with this unit.